Yo, welcome to the tech talk about our virtual theater project. What you see is what you get. My name is Erich Lesovsky and I want to explain our research project on virtual theater from the technical side. You can find the general information in the workshop talk or on our homepage or on GitHub. I will first show you the project in action and then explain the individual blocks. So let's just get started. You see here our stage, our first empty stage. We have different stages which can be switched via OSC protocol or number keys on the keyboard 1 to 4. But I will show you here the controller, and we switch off first stage, switch on the second stage. The third with a different camera position, and the fourth, which is really ugly. So we go back to the first stage. You can switch the different cameras via a gamepad. Yep. With our gamepad, you can switch different camera positions or different cameras. We have a camera manager. I will show you soon. And we can switch the cams. We can zoom in and out, change the focus. The positions are stored. You can turn off the shake, the virtual camera shake. And you can put in as many cameras as you want. Yo, and the costumes are also controlled via our OSC panel, and I will switch a few only for a little view. So we turn off our Rokoko studio meshes. Let me show you that we could boom dissolve it. And I will turn on particle effect, turn up the spawn rate, give it more gravity that it falls down. Okay, let's put it up. We can put a speed limit on it and drag the particles more or less. And a curl noise. So we make different costumes in our experiments about what is possible and what not. This is so wonderful. Huh? I love it. Yeah, and it's a little overview about the stuff we did, and now we'll explain the different building blocks. So here you see Rokoko Studio, the software which came with the Smartsuits, and they have a new version now of Smartsuit and Studio, but this is the one we worked with. And from the software, you can go live or send the recording to different engines. And like you see here, we have Unreal turned on and put in the local IP of this computer where Unreal is running on, and the IP of our second computer for the VR stuff. We need one computer per VR headset, and so we send the mocap data also to the second PC or more if you need. Don't know how many you can use. Then you need in the Unreal Engine the Rokoko plugin, and this comes with the Rokoko receiver. This has to run in the project. So you can put it in from the actors, receiver, remote. So the receiver has to be the same number, port number, as in the Rokoko Studio software. And also you have to turn on live link, source, Rokoko Studio, and then you get this entry. I didn't have to change anything here. You can see here we have a Newton mesh, skeletal mesh, and we drive it via animation blueprint. The blueprint, here you can see the animation graph to drive the skeletal of the Rokoko suit. There was a nice tutorial from Rokoko, and so you have here an actor name. This actor name is needed because the software of Rokoko Studio uses actor names, and you send the actor name data to the other programs. So here we have our dancer Natalie, and this is essential, the alpha bone mapping. It's a simple translation of bone names. Here we have our OSC in. So, and this is the OSC blueprint. You can see we create a OSC server. If a message is received, we split it up and send it to a second computer. Or every time a message is received, we send it to the OSC interface. And here we are in our dancer character, and everywhere you need this, where you need this OSC messages, you create an interface, or you get the interface here, edit it here, and have again OSC message from interface available. And here we go to the different parameters. So you name your parameter in the OSC software curl noise, and send this further with a range, a mapped range. You set the float parameter of your particle systems or whatever you have. Parameter name is set in the particle system. Here are the user exposed parameters. You create here a parameter like this curl noise trend, and then you can put it to where the curl noise here. Curl noise strength up to here. So, and then you can change the parameter via the OSC. So here we have our persistent level, which includes the OSC in, the dancers, some post-process volume, the Rokoko receiver for the motion capture data, and our screen for the dancers that they can see themselves in the VR space, like in the mirror. And like I said, this is turned on always, and we can switch with OSC or a keypad different levels in. If you have a persistent level, you can drag and drop other levels in. And to switch the levels via OC, we go to the level blueprint of the persistent level. And again, we get with our interface, we get the iMessage, the OC message. Our OC names are level 1, 2, 3, 4, 5, 6. And the parameter is 0 and on. 1. 1. And with this node, load stream level by name, we load or unload the stages, the maps. So let's talk about the costumes and also the OC switch on this. It's the same like on the other levels, and so we have a interface, we have the OC message received, we split it up to the parameters we need. So we switch characters on, off, we switch actor effects, we switch the particle parameter, and send these parameters to ground noise, gravity, drag, speed limit, spawn rate, the visibility effect of our dynamic materials we created in the construction script, 2 dynamic materials for our Newton mesh, and for the funny bot we downloaded the funny bot and the marketplace. To switch our actors on and off, we use our OC message, set the material of our actor, and set the visibility of our actor on or off, new visibility. And in the construction script, we set the visibility of all our different costumes or particle systems or whatever to false. That we have a clean start and don't have all this enabled. If you enable all this, it's a mess, and the frame rates drop down. Also, I created a kind of a gloss, a simple cape in Blender, imported it to Unreal, and work with the parameters for cloth simulation. But as you can see, it's a little bit buggy and really tricky to get good results. And here we have the particle effects. Some I did, and others are bought from the marketplace too. You can see on the control panel, we have gravity as a parameter, drag, speed limit, spawn rate. Here we have the same with lights attached. Yes, chrome balls is from the store. A little bit dark in this level, possibly. You can see it better in this environment, but not really. Okay, let's go on. You have a ribbon effect. Ribbon is an internal particle effect from Niagara. You have a trail effect from the hands of the Newton skeleton. The stone is also bought from the marketplace. Couldn't manage it myself to glue particles in this kind on the body, or if I remember correct, it was some months ago. But yeah, this is an awesome effect. Fits extremely good to this background. And you can switch the drag parameter to 0. It loses all the stones, and boom, back. Yes. So back here. And the silver rocks is nearly the same, And the fire trail effect, also from the marketplace. Here you can see the fur I created in Blender and Maya, because Blender crashed often on export of the Alembic files. And as you can see, there are also problems with lights, shadows, and stuff in the hair. In VR, you don't get the hair on the right side of the eye, which is funny and strange, and it looks horrible, but if you close your right eye in VR, then the hair groom stuff looks nice. I hope this is fixed soon. And because the Alembic file stuff is so interesting, and as you can see with physics on the hair, also wonderful, wonderful. This is our camera manager, camera controller by Janosch. He did a great job, and thanks for this, Janosch. You can put your cameras in here, as many as you want, I think, and all get the same parameters for rotation speed, reset speed, focal length, change speed, etc. And you can switch via the gamepad. I switch it fast now. Button A switches the cams. Boom, 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 boom. You can zoom in or out with the right thumbstick. If you turn off the actor tracking, you can use the left thumbstick to move your cameras. You can turn off and on the camera shake. And all the parameters are stored for every single camera. So, and this is our music player, where you can put in your own songs and trigger them via OSC messages. This means you have an OSC message, and if it's true, you activate your audio file. And also, if you want, you can print the song name out. So thank you for watching, and download the project from GitHub. Feel free to use the OSC in, the Alembic files, the camera manager, the music player, and the empty stage. Try to build some virtual theater piece or real-time dance performance, and yeah, I hope you enjoyed it. See you.